Alright, this video is going to go through lesson 5. So our warm-up here says one perpendicular bisector. So it says the image shows a triangle. And it says we want to construct the perpendicular bisector of segment AB. Okay, so if you don't remember what a perpendicular bisector is, it's going to be a perpendicular bisector is if you have, let's say we have a line segment. Draw it down here. Let's say we have a line segment. A perpendicular bisector is going to cut that right in half and be perpendicular to it. So something like this. It should cut it in half and be perpendicular. So this half should be the same as this half. So that's going to be the perpendicular bisector. So if I want to construct the perpendicular bisector, we're just going to take our ruler. I'm going to use my protractor as a ruler here. And it looks like that's right about 7.25 maybe centimeters. So if you cut that in half, it's going to be half of 7 is 3.5. I think this is actually scaled a little bit differently than what your packet is. I think in the packet it's closer to 7 centimeters. So I'm going to cut that right in half at right about 3.5, a little bit more than 3.5 since mine measures a little more than 7 centimeters. So that should be my midpoint. And then I can make a right angle with that. So I can kind of like line up my protractor with that point. And then if I mark 90 degrees up here and then connect that, that should give me a right angle. So then I should be perpendicular. And then that's going to be my perpendicular bisector. So you can see that it's cutting in half, it's perpendicular, it makes a right angle. Now it says imagine a point D placed somewhere on the perpendicular bisector you constructed. How would the distance from D to A compare to the distance from D to B? Explain your reasoning. So a point D anywhere on this perpendicular bisector, let's say D is going to be right here. The distance to A should be exactly the same as the distance to B, no matter where our point is on our perpendicular bisector. Because a perpendicular bisector, pretty much by definition, a perpendicular bisector, any point on a perpendicular bisector should be equidistant from the 2 points that we're bisecting. So any point on here should be, if I pick this point up here, the distance to A from there should be the same as the distance to B from there. So anywhere on here, that's going to be true. And that's true for any perpendicular bisector. So we're going to see how that is going to apply in the next thing here. So on 5.2, it wants us to actually keep drawing on here. So we'll kind of go back and forth here. So it says, for the first thing it wants us to do, it wants us to construct the perpendicular bisector of segment BC. So just like we constructed the perpendicular bisector of AB, it wants us to do BC. So again, your measurements might be a little bit different in your packet because I just printed this out at home, so it might be scaled a little bit differently. But looks like mine is right about 5.5 centimeters. So half of that is gonna look like right about 2.75, so something like there. And then my right angle, again, we can line it up. So my midpoint's right there. I'm going to line that up. And then 90 degrees is going to be right here. And if I connect those, that should give me a line that's perpendicular. Looks like maybe I was a little bit off. Maybe not. There's my right angle there. And then let's see what the next thing is. So that's our second perpendicular bisector. And the second step here says, use a colored pencil to draw segments PA, PB, and PC. So it wants you to use a different color than you've been using, and that part's going to be important, especially when you're like looking back at this. If you're getting ready for the test and you're looking back at this, you want to know what's going on. So use something different, like a different color than you've been using. I'm going to pick maybe this turquoise color. So it wants us to draw, oh, and I forgot that this point right here, this point we're calling that P, where those two perpendicular bisectors intersected. And now we're drawing PA, PB, and PC. So PA, just want to connect those. I'm using my different color here. PA, P, that's PC, and then here's my PB. All right, so those are my PA, PB, and PC. And then it's gonna ask, how do the lengths of these segments compare? So if we're looking at these, my turquoise lines here, they're asking, how do these lines compare? How do these line segments compare in length? They're going to be the same length. So let's think about how we know that. So let's look at this. If I am looking at this point P as a point on the perpendicular bisector of AB. Remember in the warm-up we talked about any point on this line, on this perpendicular bisector, will be equidistant from A and B, right? So that means that if P is on the perpendicular bisector of segment AB, then PA must be the same length as PB. And then if we look at P as being on this perpendicular bisector of BC, then the same thing is true. This point P has to be the same distance from B as it is from C, because it's on the perpendicular bisector of BC. So that means that this length and this length have to be the same. So if these two lengths are the same and these two lengths are the same, then all three of them have to be the same. So these are all congruent. All of my turquoise lines here. Okay, so let's look at the next question. Imagine the perpendicular bisector of segment AC. Will it pass through point P? Explain your reasoning. So now we're imagine that we drew the perpendicular bisector of this side here. Will it go through P? And how do we know why or why not? So if you think about this, we know that P is equidistant from A and C, right? So if P is equidistant from A and C, in other words, the distance to A is the same as the distance to C from P, then it must be on the perpendicular bisector of AC. So it's kind of like the inverse of the reasoning we were using before. Before we were saying if P is equidistant from, or we were saying if P is on the perpendicular bisector of AB, then PA must be the same distance as PB. Now we're saying if PA is the same distance as PC, then P must be on the perpendicular bisector. So it works both ways. So let's go ahead and write that. So I'll say here, P must be on the perpendicular bisector of AC because PA is congruent to PC. Okay, so now it wants us to actually construct the perpendicular bisector of segment AC. So when we do that, that should go through P. So I'm going to go back to my purple that I was using before. And I'm going to measure to find the midpoint. That's right about 7. So I'm going to mark at, it's a little bit less than 7. So half of 7 is 3.5. So I'm going to mark a little bit less than 3.5. Maybe something like that. And then I want to make that right angle. I'm going to turn it upside down so that my line will go down here. Okay, so as you can see, my third perpendicular bisector didn't go exactly through that same point. That's just due to human error. I probably didn't do exactly the midpoint or exactly a right angle on one of these, or maybe all of them. I was a little bit off. But it should go through the same point. So let's just pretend this is all going through the same point there. So let's see, what's the next question? Now it says construct a circle centered at P with a radius PA. Okay, so I'm going to take my compass. So it wants PA to be my radius and P to be my center. So I'm going to take this here. This compass is a little tricky because it locks. Okay, so I want PA to be my radius. So I'm going to get it to where I want it to be. Okay, that looks pretty good. And then I want to draw my circle centered there. So I'll move this up a little bit so you can see a little better. Okay, so there's my circle. That actually worked out a lot better than I expected it to. So you'll notice that my circle, I made PA my radius, and then my circle also went through points B and C, the other two vertices of the triangle. So the last question here is, why did that happen? Why does the circle also pass through points B and C? Well, if you think about it, I made PA my radius. We know that PA is the same length as PB and PC. So if my circle was centered at P, and we know a circle is a set of points that are all equidistant from a center point, then this circle with radius PA should be the set of points that are all a distance, this same distance away from P. So if C is also that distance away from P, then that should also be on the circle, and same with B. So if these are all the same length, all of these points should be on the circle if we're centered here. Okay, so what we just did was we just constructed something called the circumcenter. So this point right here, that's called the circumcenter. And the circle that we drew is called a circumscribed circle. So the circumcenter, we construct that by finding the intersection of the three perpendicular bisectors of the sides. And then that point is going to be equidistant from the three vertices of the triangle. And because that point is equidistant from the three vertices of the triangle, that point is going to be how we can draw a circle that goes through all three vertices. We just center it at that point, make our radius the length from our circumcenter to one of the vertices, and then that should be our circle that's going to go through all 3 vertices of the triangle. So this is useful for like if you're specifically the circumcenter part, not necessarily the circle part, but the circumcenter part is useful if you're trying to find like a location that's the same distance from 3 different places. So like you'll encounter some questions that are like, if I want to build a water tower that's equidistant from these 3 towns, where should I put it? So finding the circumcenter would be what you want to do there. Yeah. So that is what a circumcenter is, and that's how we make it. So let's go on to this last part here. This last part says wandering centers. It says construct the circumscribed circle of your triangle. So we have 3 different triangles. The idea was you're supposed to like pick one, and then everyone in your group, like at least one person in your group has one of them, so you can see the difference. I'll go ahead and go through all 3 though. So we're going to construct the circumscribed circle of each of these triangles, and then we're going to see what we notice about like the location of the circumcenter in each triangle. So let's go ahead and make the circumcenter. So I'm going to start with this right triangle. I'll find my midpoint. Make that right angle. And again, these aren't going to be perfect. But if you think about in real life, usually if you were trying to apply this, it wouldn't need to be exactly perfect. You just want it to be the right idea. Like if I'm trying to find a location that's equidistant from 3 towns to put a water tower, it's not a big deal if I'm a few feet off from the exact location that I need it to be at. And technically, we only need to do 2 perpendicular bisectors to do this, but it's a good idea to do all 3 just to make sure that you didn't like really mess up. This one looks like I did pretty good. So if I make my 3rd perpendicular bisector here, it's going to be something like this. We're going to intersect right there on the hypotenuse of this right triangle. So one thing to note about the circumcenter is it's not always going to be like inside in the middle of the triangle. For a right triangle, it'll always be on the hypotenuse. Let's look at this one. So it looks like that one's going to be there. And then if we look at the last one, this obtuse triangle, and I'm realizing that I should have extended this longer because the intersection point is going to be way out here. So for this obtuse triangle, my circumcenter ended up being outside the triangle, which, if you think about it, that's where it has to be if I want all of those distances to the vertices to be the same. I need this distance to be the same as that distance and the same as that distance. So it has to be outside of the triangle in order for that to happen. Okay. So that's it for lesson 5. The next couple lessons are going to be about something called the incenter, which is kind of similar to the circumcenter, but also distinct from the circumcenter. So we'll do that next.